This man is almost deaf, unless he is wearing his glasses. When he takes them off, sound diminishes to a whisper. Because in his glasses are 4 tiny plastic-covered pieces of metal that amplify sound. They are called transistors and powered by tiny batteries no larger than a pill. The electron tube gave the world the first practical amplification of sound. Electron tubes made possible the innovation of such things as radio, television, and even talking motion pictures. In time, tubes were produced much smaller in size. However, many ideas which were theoretically feasible were not possible to develop because even the smallest tubes required a relatively large amount of power and produced considerable heat. Then, in 1948, a group of scientists in the laboratory of a telephone company in the United States was researching in a field of metals called semiconductors. They wanted to find out what greater scientific value these metals might have, and ended up by winning the Nobel Prize for inventing the transistor. Here at last was a device so tiny that several would fit inside a thimble. They can do the same job as electron tubes and require only a fraction of the power tubes used to operate and remain cool while functioning. Transistors are not an improvement on electron tubes. They are entirely different in construction and work as a completely new principle. This enlarged diagram shows that a transistor is a sandwich made of 3 layers of a semiconducting metal called germanium. The first layer is the emitter. The middle layer is the base. And the third layer is the collector. The emitter is a reservoir of electrons. There is a barrier, like a dam, in the base. The height of this dam may be raised and lowered by a very small amount of electric current, thus regulating the flow of electrons from the emitter to the collector. The electrons that flow over the dam deliver much more power to the collector than the amount of power needed to raise and lower the dam. This laboratory model telephone shows how sound carried by electrical impulses is made louder by the transistor. Electrical impulses become so weak in traveling through miles of wire that they hardly operate the receiver. A circuit which has a transistor at the receiving end allows impulses to come out as loud as they went in. Transistors take so little power that if you soak a piece of blotting paper in acid or even wet it with saliva and wrap it around a silver coin, it will provide enough electricity to operate a transistor. Much of the work in manufacturing transistors has to be done through large magnifying glasses in air-conditioned chambers with temperature and humidity strictly controlled. But new machines have been developed to lick the production problem. This one does part of the job of aligning the 3 tiny layers of germanium and attaching hair-thin wires. This is an inspection machine which uses transistors to sort and inspect transistors. Within the past 5 years, this automatic machinery has increased the production of transistors from 1 million to 60 million a year, and is shortly expected to reach 300 million. Transistors have already made possible many advances in all fields of communication, benefit millions of people. Shipped to many parts of the world, transistors have found their rightful place in the field of electronics. Transistors are helping to make all kinds of things available cheaper and in greater quantity. by controlling the machinery that makes automation possible. They use so little power that they make possible simpler, more dependable, and less expensive automatic machines. Transistors are at home in the sky. If you fly in an airplane, they will serve you in miniaturized navigation instruments, in radar, which can see the weather ahead, and an automatic pilot, which keeps the plane on course without human aid. After the pilot has taken the plane aloft, he sets a compass course for his destination, turns on the automatic pilot, and relaxes. If air currents deflect the plane from its course, the automatic pilot senses the change, and the transistors turn on an electric current and amplify it to operate the plane's rudder and elevators. Transistors are soaring into outer space. The satellite contained a tape recorder and 2 radios equipped with transistors. This machine records a wealth of scientific data as the satellite spins through space. And when it is over a point where the information can be received, the tape recorder plays it back, and the radios transmit it to scientists on Earth. If this equipment used vacuum tubes instead of tiny transistors, the satellite would have to be several times larger to carry the bigger tubes and batteries, plus an air conditioning system to keep them cool. Not all miniature tape recorders spend their time spinning through space. Here, one is being used at a seminar of students and professors from many lands at an American university. When they return to their own schools, students will take copies of these tapes so that the benefit of this seminar can be spread throughout the world. The transistor is extending the power of man's brain in wonderful calculating machines called computers. The computer is really an electronic abacus. On an abacus, mathematical problems are solved by moving beads with the fingers at the rate of a few a second. In a computer, electric impulses replace the beads, and thousands of transistors move them at the rate of 2 million a second. The computer can solve problems in minutes that would take human mathematicians months or even years to figure out. To help farmers produce more milk per cow, representatives of the United States Department of Agriculture collect information from farmers on the amount and kind of food that a cow is given, the length of time in pasture, the amount of milk and butter fat she gives, and many other items. Hundreds of thousands of facts are fed into a computer, and in a few minutes it turns out a complete analysis of each cow. This project would be impossible without the computer. It would take a staff of human mathematicians so long that the answers would be worthless by the time they figured them out. From the computer, each farmer gets a report telling him exactly how much it is costing him to feed each cow and how he might change his feeding practices. Now, doctors can see your heartbeat when you're walking around with the aid of transistors in a new type of electrocardiograph. This part of the machine is really a small radio transmitter in which transistors amplify the heartbeat and broadcast it to a recording machine. Before this machine, doctors could see the action of the heart only when the patient was immobile, connected to the electrocardiograph by wires. Now they can study the heart when it is under the strain of physical activity. Another medical device improved by transistors is the electroencephalograph, which measures brain waves and is used for diagnosis of epilepsy, brain tumors, and to study the action of the brain under unusual conditions. Before this machine was miniaturized with transistors, it had to be permanently installed and was available only in large city hospitals. Now it can be carried in the back of a car, and several small hospitals can own one jointly and move it speedily. With this tiny capsule, doctors can see the pressure inside your body. It is only 1 centimeter by 3 centimeters in size, but it contains a battery, a pressure diaphragm, and a transistor. The amount of pressure on the diaphragm creates a varying electrical impulse, which is amplified by the transistor and broadcast to an oscilloscope. When swallowed, the pressure of the various organs of the body through which it passes acts on the diaphragm and creates a picture of what is happening inside your body. If you were blind, transistors would help you to see with your ears. In this school, blind students are being taught to do electrical and radio work with the aid of transistorized instruments. The transistor converts the kind and strength of electrical current into sound so that the blind worker can determine the strength of a current. Another instrument to aid the blind uses a phototransistor to interpret different colors or shades of brightness into sound tones. As the surface gets darker, the tone gets lower. When pointed at a light surface, it emits a high tone. The development of the transistor was based on ideas and observations of many men in many lands who were not trying to invent anything. In chemistry, Dmitry Ivanovich Mendeleev, a Russian, predicted the existence of the element of which transistors are made in 1871. In mineralogy, Clemens Winkler, a German, discovered this element in 1886 and named it germanium. In physics, Michael Faraday, an Englishman, and E.H. Hall, an American, made significant observations in the mid-19th century on the flow of electrons through metal. But perhaps the greatest single contribution was made by the German mathematician Max Planck, who in 1901 developed the quantum theory. Now, for the first time, scientists had a basis for understanding the flow of electrons through solids. Based on his ideas, theoretical physicists all over the world developed the science of quantum mechanics, which made the invention of the transistor possible. None of these men worked alone. Through reports of their work translated into many languages, there was a free exchange of ideas so that each could borrow from what others had learned. Each stood on the shoulders of those who went before. In existence only little more than a decade, the transistor and the miniaturization which makes it possible has already brought about great strides in many fields, and it has just begun to help us add to human health, safety, and welfare. Perhaps the most important of all its uses is in laboratory equipment, helping scientists to work for us by finding still unconceived benefits which pure science may bring. Meanwhile, the transistor has magnified man in all his works. Lengthening, strengthening, and speeding his stride in every direction. The transistor has given men a great new mechanical advantage, making them giants among living things in both old and new endeavors. With the dream of the ages come true, man has a means for controlling major natural forces of his world with a little giant that he can hold in the palm of his hand.